All right, so I'm going to review Chapter 6, the conic sections. Conic sections are different curves that are found by slicing into a cone. The first one we're going to study is the parabola. We have two types of parabolas. The x equals y squared is the horizontal or sideways parabola. You'll recognize a horizontal parabola because x is to the first, y is to the second. That opens to the right if y squared is positive. It opens to the left if the y squared is negative. If it's y to the first and x to the second, that's our vertical parabola, the one we've used the most in this class. It is a function, and we studied it back in the function chapter. If we put a negative in front of this, it does flip it upside down. The next conic section is the circle. A circle has an x squared and a y squared. They're both positive with equal coefficients. So both of those just have ones in front, but any equal coefficients of the x and y squared that are positive will be a circle. And the number on the end, if it's a positive number, that represents the radius squared. So this will be a circle at the center, at the origin, with a radius of 4. So if the coefficients are different in front of the x squared and the y squared, that makes it elliptical shape. Not the same amount up and out, so different coefficients, but still positive, so they come together. This makes it an ellipse. If it is minus x squared and minus y squared, there's a minus between the square terms, then it is a hyperbola. The curves go away from one another. X squared is positive and y squared is negative, makes the curves open left and right on the x-axis. X squared minus y squared is a sideways or x-axis hyperbola. If it's y squared minus x squared, it doesn't matter if the coefficients are the same or not on this, by the way. But if it's y squared is the positive one and x squared is negative, it opens up and down on the y-axis. Okay, so starting with number 107 on your study guide.
Okay, what did you say on the last one?
If the y squared is the positive part minus the x squared, then it opens up and down. The hyperbola curves go up and down. Okay, 107. So we recognize this as being a sideways parabola because x is to the first, then y is squared. Now there's also a y to the first, but that's not what we're comparing. We're comparing the biggest exponents on each variable. So for the y's, the biggest y is squared. The biggest power of y is squared. And the biggest x value is to the first. That's what makes it a sideways parabola. So we know this is going to be a parabola opening to the left, the negative. So that narrows down your choices between A and D right there, just knowing that it's a left opening parabola. But to find the exact parabola, you'll need to find its vertex or some other t-table points to pick between those two. To find its vertex, we have a vertex formula, negative b over 2a, and notice we've used that a ton of times in the study guide, so that's an important little formula. Negative b over 2a normally gives you the x shift of a parabola, but because this is an inverse equation, it will give you the y shift. Everything's inverted, x equals y squared, so it's not a function. All right, so negative b would be this negative of 6 over 2 times the a value, which is negative 3. Negative 6 over negative 6 is 1. Remember, it's the y shift. 1 is the y shift. Then we plug that number back in for these y terms because that does represent the y value, as I said, and that will give you x equals the x shift. So the x shift will be negative 3 times 1 squared plus 6 times 1 minus 4. This can be found quickly by punching it on your calculator, but I'm doing this by hand and getting a negative 1. So negative 1 is x equals. So the x shift is negative 1, the y shift is 1. And that will tell you the correct answer is A. A is shifted back 1, up 1 for the vertex, then opening to the left. Now if you did need to find another point on this, you could do it with a t-table. So I know when you did your homework on Math Excel, you had to find a point to aim towards to get a correct parabola. So you'd pick some y value, anything that you wanted to plug in for y, see what x was. As long as you get an xy point that fits in your 10 by 10 grid, that will give you an acceptable point. So let's say I plug in y is 2. Y is 2, right? So I plug it in on the t-table for the y side and look for x. So back in the original problem, x would be negative 3, plugging in 2 for y, 2 squared, plus 6 times 2 minus 4. So that's negative 12 plus 12 is 0 minus 4. Now I can say that another exact point on this graph is that x is negative 4, so back 4 and up 2 to get the right shape of it. Another sideways parabola. This time it's in a completed square form, so we can see the shifting rules without having to do negative b over 2a. We should know that it is moved up by 5 because what's grouped with the x, what's grouped with the y in this case, but whatever is grouped or in parentheses, we've always changed the sign of that because the formula says to, but it's been the same formula for everything we've done. The negative sign changes that to a positive 5 y shift. So the vertex is at positive 5 for y, and that means that's the x shift of negative 1. So I know it's a parabola, move back 1, up 5. I know that it's a positive in front of y squared, so it's going to open to the right, again because it's x to the first, it's a sideways parabola. And 5/8 just affects how wide the curve is. So looking at your choices, let's see. We only have one that fits that description of move back 1 and up 5, which is choice D. But if you had to, then go further. And I recommend you do this anyway, just to be sure on your final. Pick one other point to know for sure that you got the right graph. So pick something for y, let's say like 6. Remember, I'm picking for y. It's a little backwards from what we normally did in the earlier chapters. But picking a y value, x will be 5/8 times 6 minus 1 squared minus 1. That can quickly be, that's 5. That can quickly be typed in your calculator. 5/8 times 1 squared is 1 minus 1. 5/8 minus 1 is just a small fraction below the axis. It's at negative 3/8. So look for the graph that's back a little bit, back about a half, and up 6, and that verifies that it's going this way, because back a half and up 6 is about right here, and that tells me the points are going that direction. Anyway, if you don't like that point, just shop for another point. You know, sometimes we prefer to get a point that's not a fraction, so put in something else, maybe try 7 for y, get a different point to use to verify. The more points, the better. All right, any questions on that? All right, 109. So I suspect this to be an ellipse because I have x squared and y squared, and they're both positive, which means they're coming together like the circle does, but they have different coefficients. So that fits this pattern. Where is it? This pattern where different coefficients for the x and y is squared. Standard form for an ellipse and a hyperbola, these figures, the ellipse and the hyperbola, you should get them equal to 1. You get an x squared over